Dear students, in the last class, we have studied about the covalent bond, that is valence bond theory and hybridization. We have studied the various types of the hybridizations, their structures and also the shapes of the molecules. Today, let us study about another concept known as resonance. It has been observed that some covalent compounds can be represented by different Lewis structures which differ with respect to the positions of electrons. But none of them can describe all the properties of the compound. For example, ozone can be represented by two Lewis dot structures 1 and 2 as shown below. In all the three oxygens, we have the same number of electrons. In each of these structures, there is one OO single bond and one O double bond O bond is present. OO bond length is 148 picometer and O double bond O bond length is 121 picometer. But the two O single bond O bond lengths in ozone are equal and the bond length is 126 picometer. This shows that O single bond O bond length in ozone is intermediate between the single bond length and the double bond length. To explain such observations, a new concept called resonance was introduced. According to this concept, the real structure of ozone is an intermediate of structure 1 and 2 called resonance hybrid. These are also called canonical structures. We can define the resonance as when a covalent molecule is represented by more than one Lewis structures and when none of them describes the molecule accurately, then the correct structure of the molecule is the hybrid of all the Lewis structures. This phenomenon is called resonance. Resonance stabilizes a molecule. Resonance hybrid has lower energy than any one of the contributing canonical forms. More the number of canonical forms, higher the stability of resonance hybrid. Now let us study what are the conditions for writing resonating structures. Number 1, the different contributing structures must have the same positions of the atoms. The contributing structures must have the same number of paired and unpaired electrons, which differ only in positions. The contributing structures for a molecule must have nearly the same energy. In all the contributing structures, the like charges should not be placed on the adjacent atoms. Now let us study here the resonating structures of various molecules. The first one, let us consider the carbon dioxide. Carbon dioxide can be represented as C double bond O, C double bond O, where each carbon contains the 8 electrons and also oxygen satisfies the 8 electrons to attain the octet structure. The same thing can also be written in other two forms, where in one form, one oxygen atom gets positive charge, another oxygen gets negative charge, and vice versa. In case of carbon monoxide, the resonating structures are given. Here in this, the positive charge will be on the carbon in one resonating structure and positive charge will be on the oxygen on the another resonating structure. Like this, we also have the structure for nitrous acid and also the nitric acid. Students, go through these, the various structures of the molecules and their resonating structures. Even in radicals, we have a carbonate ion which is shown by 3 resonating structures. In this slide also, we have shown the nitrite anion, ozone molecule, and also the benzene. So this is a slide that shows the resonating structures of sulfate ions. Students, you must able to practice writing the resonating structures of the various molecules and also the radicals. This slide also shows the resonating structures of the nitrate ion as well as the benzene. Now coming to the another term, resonance energy. The greater the predicted stability of a resonance contributor, the more it contributes to the resonance hybrid. The greater the number of relative stable resonance contributors, the greater the resonance energy. The more nearly equivalent the resonance contributors, the greater the resonance energy. This slide also shows about the definition of resonance and also the various examples of resonating structures of the benzene. The resonance structures are formed due to delocalization of the electrons and not by changing the positions of atoms. The delocalization of electrons is shown using curved arrows. The energy of resonance hybrid is always less than the energy of any of the contributing resonance structure. The increase in electron density at one position with corresponding decrease at another position is called resonance effect. There are 2 types of resonance effect, namely plus resonance and minus resonance. Groups attached which donate electron shows positive resonance effect, while groups attached which withdraw electrons shows negative resonance effect. The actual structure, that is resonance hybrid, of a molecule has lower energy than any of the contributing form, and hence the resonance is a stabilizing phenomenon. Greater the number of contributing structures, greater is the stability of the resonance hybrid. All the structures do not contribute equally to the hybrid. Greater the stability of resonance structure, larger is its contribution to the resonance hybrid. In this, once again, the resonating structures of ozone, carbon monoxide, and hydronium ions are given. Students, go through this much about the resonance. Thank you.